Well, students of 12th class, the topic for you in the electrochemistry unit is corrosion. Corrosion of metals. First, let us know what this term means. Gradual eating up of metals by the gases and water vapors present in air is called corrosion. What does this mean? This means that when metals, and especially which metals? The more reactive metals like zinc, potassium, sodium, iron, these are more reactive metals. When these metals are exposed to air, the moisture, the pollutants that are present in the air, what happens to those metals? They gradually begin to get ate up. This gradual eating up of these metals deposits a layer over these metal surfaces, and that layer, that oxide layer, is known as rust, and this whole process is known as corrosion. Now, corrosion simply means the eating up of metals by the presence of air, water and moisture that may be present in the atmosphere. This whole process is known as corrosion of metals. Now, this corrosion of metals depends upon the reactivity of metals, thereby meaning that metals which are more reactive in the electrochemical series, they get corroded more quickly as compared to those which lie in the lower level of electrochemical series. Now, before moving further, let us go to the mechanism of corrosion. How corrosion takes place. In corrosion, what happens? The metal that gets corroded basically becomes an electrochemical cell. As you know, in electrochemical cell, redox reaction takes place. By redox reaction, we mean that oxidation and reduction take place simultaneously. For this purpose, let us go to the mechanism of this corrosion. Here I would like to add one more point. If corrosion takes place in iron, this corrosion is known as rusting. So let us move to the mechanism now. What happens here? Please see, this is a piece of iron. In this piece of iron, what happens? It gets exposed to air, water, and in the process what happens? The iron, this Fe, it begins to lose electrons to become Fe2 positive ion. That means oxidation has taken place. Here in this part of this metal, it becomes what? It becomes anode of the electrochemical cell. At anode, what happens now? Your iron that loses electrons to become Fe2 negative, and this process is known as oxidation. So in this part of this metal, oxidation has taken place. Then in second part, this is cathode. What happens at cathode? Your hydrogen and carbon, they combine to form carbonic acid. Now where from this hydrogen and this carbon dioxide has come? This water and this carbon dioxide have come. They have come from the atmosphere. From the atmosphere, what happens? Your water and your carbon dioxide, they combine to form carbonic acid, and this carbonic acid at cathode, that ionizes, that decomposes to form H positive ions and carbonate ions. And as a result, the electrons that have been lost in oxidation, they get added to form H ion, and this is reduction. So in this part, what happens? Oxidation happens, and here what happens? Reduction takes place. That is, here loss of electron takes place, and in this part gain of electron takes place. That is, a redox reaction has taken place. So concluding corrosion, what happens? your Fe that loses electrons, 2 electrons to become Fe3 2 positive. That Fe2 positive again gains electron to become ferric ion, Fe3 positive. Fe3 positive further adds hydrogen to form ferric oxide, rather hydrated ferric oxide. This is water of crystallization. So basically rust is hydrated ferric oxide. So it is all because of hydrated ferric oxide that corrosion takes place. So this is all about corrosion. Now there are some factors which are responsible for corrosion. That means there are some factors which increase the rate of corrosion. For example, these are some factors. Factors of corrosion. First factor of corrosion is reactivity. As I said earlier, that reactivity of metal plays a vital role in corrosion. The metals which are more reactive, which fall in the electrochemical series in the beginning, they are more prone to corrosion. And if those metals which are lesser reactive, they don't get corroded. For example, your gold, your silver, your platinum, these metals do not get corroded due to their low reactivity. On the other hand, your iron, your zinc, your potassium, your sodium, they are more reactive metals, so they get corroded. So reactivity has a role. Reactivity is a factor in corrosion. Then another factor is impurity present in the metal. If a metal contains more impurities, there are more chances of its corrosion. So higher the impurity present in the metal, quicker will be the rate of corrosion. Then we have another factor responsible for corrosion, that is electrolytes. Presence of electrolytes in the metal. Electrolyte, as you know, electrolytes are those substances through which electricity can pass either in molten state or in solution state. So if electrolytes are present in the metal, it increases the rate of corrosion and vice versa. Then another factor, that is moisture. Higher the moisture content present in the metal, there are more chances of corrosion. And finally, the uneven surface of the metal. That means if the metal has some depressions in it, there is more probability, there is more possibility of corrosion of that metal. So these are some factors which are responsible for corrosion. And finally, I will come to prevention. How to prevent corrosion? Corrosion must be prevented. Why? Because if corrosion is not prevented, then there can be huge loss to the economy of the country. Because these metals, they make railway tracks. These metals, they make most of the tools. They make bridges and what-not. Your metals play a very vital role in the economy of the country. So there must be some methods which must be taken to prevent corrosion. These are some methods of corrosion. For example, first method, prevention of corrosion. First method in this is barrier protection. By barrier means obstacle. What we do, we create a barrier between the metal and the environment and the air, so that air does not come in contact with the metal, and this type of this prevention is known as barrier protection. Another protection is sacrificial. By sacrificial means we give sacrifice of one metal to prevent the other. For example, what we do, we deposit a zinc coating on iron to prevent iron from corrosion. What happens in the process? When we deposit a layer of zinc over this iron, air comes in contact with zinc. Zinc is more reactive as compared to iron. So your zinc that sacrifices itself to prevent iron. So this is another method of prevention of corrosion, that is sacrificial. Then this is another method, alkaline solution of phosphate and chromate salts. This is a modern technique that has been adopted to prevent corrosion. Some alkaline solutions of phosphate and chromate salts, if we put a metal in that very alkaline solution, there are so many chances that that metal does not get corroded. Here and the last, not last but second last, that is galvanization. Galvanization is more or less like sacrificial. What happens in this? This is special method for preventing iron. What we do? We deposit a layer of zinc on the iron, and this process is known as galvanization. So galvanization is a special term used for preventing iron by depositing a layer of zinc over it. Then we have last method of prevention, that is electroplating. What we do in this method? We deposit a layer of one metal over other metal to prevent a metal from corrosion. For example, we mostly find that some people wear these artificial jewelries. What we do, for example, inside we have aluminium, and then we deposit a layer of that gold or silver over it. This process is known as electroplating. This also is a method for prevention of corrosion. So this is all about corrosion, and that is all about electrochemistry unit of your syllabus. Thank you very much.